At this point, you understand the methods. Matrix acidizing. Hydraulic fracturing. Now the problem changes. It is no longer how these methods work. It is deciding which one the well actually needs. Wrong selection does not reduce performance. It applies the wrong mechanism to the reservoir. And the result is simple: no improvement. This lesson builds the selection framework. 3 variables: permeability, damage level, and reservoir type. This is not a checklist. It is a diagnostic sequence. And it determines the correct treatment before any design begins. Start with permeability. This is the first question. Can the reservoir deliver fluid at all? High permeability. Flow capacity exists. Production is limited by damage near the wellbore. In this case, the solution is to restore flow. Matrix acidizing is sufficient. Now move to intermediate permeability. This is where most mistakes happen. The formation can produce, but not efficiently. Damage may be present, or intrinsic permeability may be limiting. You cannot assume the method. This requires evaluation. Now low permeability. The formation cannot transmit fluid effectively. Even with zero damage, production remains low. Acidizing does not solve this, because it does not change the rock. Hydraulic fracturing is required. Now ultra-low permeability. Without fracturing, there is no economic production. This is a hard boundary. So permeability answers the first question: do you restore flow, or do you create it? Now move to damage. Damage controls treatment intensity. Light to moderate damage. The rock has permeability, but flow paths are partially blocked. Typical sources: drilling fluids, scale, fines migration, clay swelling. Here the solution is direct. Remove the blockage. Matrix acidizing restores permeability. Now severe damage or deep impairment. The critical question is depth. If the damage extends beyond the reach of acid, the treatment will not contact it. Acid fails even if correctly designed. Now combine this with low permeability. Even if damage is removed, flow is still limited by the rock itself. In both cases, fracturing becomes necessary. Now the key warning: not all skin is damage. Completion effects, partial penetration, perforation friction. If you misidentify the source, acidizing will not change performance. So damage must be measured, confirmed, and located. Otherwise your treatment is blind. Now reservoir type. This defines what methods are even possible. Carbonates are reactive. Acid can dissolve the rock. This allows matrix acidizing and acid fracturing. Sandstones are different. They contain quartz and clays. These require specific acid systems. Standard acid does not work. Incorrect fluid selection creates damage. Now tight formations. Shale, tight gas, tight oil. These do not respond to matrix treatments. The permeability is too low. Fracturing is required. So this criterion does not optimize. It eliminates options. If the rock does not allow the mechanism, that method is removed. Now combine the 3 filters. High permeability with damage present. Restore flow. Acidizing is sufficient. Low permeability. Create flow. Fracturing is required. Now combined case. Damage and low permeability together. If you fracture without removing damage, the fracture operates under restriction. If you only acidize, you remove damage, but flow is still limited. So the sequence becomes critical. Remove damage first, then create flow. Now carbonate with low permeability. Acid alone is not enough, but the rock reacts. So the solution becomes acid fracturing. This combines fracture creation with conductivity generation. Now the key principle: no single variable defines the decision. It is the interaction that determines the method. This matrix is not for reading. It is for interpretation. Start with permeability. This sets the direction. Then move to damage. This adjusts the treatment. Then reservoir type. This confirms feasibility. Now apply it. High permeability with no damage. No stimulation. The performance issue is elsewhere. Moderate damage in high permeability. Acidize. Low permeability regardless of damage. Fracture. Now mix systems. Damage plus low permeability. Combined treatment. Do not default. Use the matrix as a structured decision. This is the process you follow in the field. Step 1. Measure permeability and skin. Without this, everything else is assumption. Step 2. Identify what creates the skin. Is it formation damage or completion effects? This determines whether treatment is even required. Step 3. Define reservoir type. This controls fluid selection and method applicability. Step 4. Determine stress conditions. This defines fracture design, not method selection. Now the rule: never start with treatment. Always start with diagnosis, because treatment without diagnosis is just trial and error. Permeability determines whether flow must be restored or created. Damage determines treatment intensity. Reservoir type determines which methods are possible. Some treatments restore flow. Others create new flow paths. Confusing these leads to failure. Final point: selection is not based on preference. It is based on identifying the dominant limitation and applying the correct mechanism. This lesson is not a collection of rules. It is a decision structure. You now have a sequence. Start with permeability, define the flow limitation. Then evaluate damage, confirm whether flow can be restored. Then identify reservoir type, determine which methods are viable. Finally, define stress conditions to guide treatment design. This sequence must be followed. Not partially applied. Not interpreted loosely. Now understand the implication. Every stimulation design depends on correct selection. If the selection is wrong, design quality does not matter. The treatment will not solve the problem. This is the shift in Module 4. From understanding methods to applying them correctly. The next lessons build on this. Not by introducing new methods, but by refining how decisions are made and how treatments are integrated. If the foundation here is correct, everything that follows becomes systematic. If not, all decisions remain uncertain.